Okay, so what we're going to look at today is the beautiful symmetry properties that are associated with circular functions or the unit circle. And it's worth noting that the quadrants of the Cartesian plane are divided up and they go quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so that's an important aspect of what we're going to do. And again, it allows us to sort of quickly refer to a particular quadrant. So rather than saying bottom left-hand side or anything like that, I just say we're in quadrant 3 or quadrant 2. Right, so using symmetry, we can determine relationships between the circular functions for angles in different quadrants. Okay, and this is pulled out of Cambridge. All right, so we've got quadrant 1 here, and cosine and sine give us the x and y values. And it goes on to then explain that if we do pi, take away the value there, we're going to get sine theta, which is negative a. What on earth is all of this? Okay, so what we're going to do is try to make sense of this without ever having to refer to this diagram at all. Okay, all right, so in summary, okay, well, let's not even summarize that. All right, let's just go through this. Okay, so how do I read the following? Okay, so what this is saying is that we're going to go and start. So here's our unit circle. And it's saying basically we're going to go to pi. All right, that's where we're starting. And we're going to add an angle. Okay, and theta, when we add an angle, will always be between 0 and 90 degrees or 0 and pi on 2. Okay, so this one here means that we want to get like an angle somewhere down here, which is pi plus an angle here. Okay, and what we want is the sine of that value. Okay, that's what we want. We want the sine of that value. All right, now what does that mean? Well, what I'm going to do is use some symmetry properties here. So I'm just going to go back over to this thing here, the unit circle. I'm going to say that, let's just say that theta, I'm just making this up, all right, but let's just say that theta, for argument's sake, is equal to 30 degrees, okay? Now we want to get the value of sine of pi plus theta. Okay, that's what we want to do, sine of pi plus theta. So here we are at pi, which is 180 degrees, and we want to go over to here. Okay, so what I essentially want at that coordinate, I want, so the coordinates here, which are x and y, I want to work out what that one is going to be. I want the y value, because that's what sine is, it's the y value. Okay, now for reasons that you'll see coming up is we won't be able to evaluate this one here, which is the sine of 210. Okay, we won't be able to work out straight away the sine of 210. All right, so what we've got to do is convert this into something that we will know how to work out. And what we will know how to work out is first quadrant angles. Okay, we won't be able to work out second, third, and fourth quadrant angles. We will know how to do these ones here. All right, so what do we know? We know that this value here is going to be negative. Okay, because that's the y value. The y value there is going to be negative, and it looks to be roughly got 1, 2, 3, 4, 5. This looks like roughly negative 0.5. Okay. All right. So how are we going to get this if we only know first quadrant? Well, what we do is we actually say, let's just do this. Why don't I, in the first quadrant, write theta up, and I will be able to get this y value here. And if I drop a negative out the front of that value there, it will then swap down to be this value here. Okay. So going back to the notes, what that is basically saying is the sine of pi plus theta is actually equal to negative sine of theta. That is basically saying, why don't you just go find the sine of theta in the first quadrant, which will be this value here, stick a negative sign out the front, and then you're going to get this value here. Okay. So remember, what we want to target is first quadrant angles. That's a really important thing. We can't evaluate second, third, and fourth quadrant angles. We want to turn them all into first quadrant angles. Okay, so that's the aim of the game. All right, let's do this one here. The tan of 2 pi take theta. Okay, so we've got 2 pi, which will take us to here, and we're going to go back theta, whatever theta is. So we want to get the tan of that value there. Okay, so it's going to hit the tangent there. We want to know what that will be. Now notice that's negative. Well, what would we do? We would turn this into a first quadrant angle, right, which is going to hit there at the positive angle. And then why don't we drop a negative sign out the front of that, and it will swing it down to that point there. So what I basically know is this answer here is going to be exactly the same as negative tan of theta. It'll give us exactly the same result. All right, I'm just going to clear out some of this stuff and redraw these unit circles because you're just going to have to draw lots of these crappy unit circles. All right, let's do this one. So there is 180 plus theta. So we've gone 180 and theta more. Remember, theta is like an angle somewhere between 0 and 90. How did I know it was there? Because it's just convenient to put it there. But you could put it there, you could put it there, you could put it there. As long as it's between 0 and 90 more than 180, that's fine. All right, so what we want to do is work out the tan of this value here. So remember, we draw a line there. Here is the tangent. And what we want to know is where it's going to hit there. Well, wouldn't that be exactly the same as just getting the tan of theta in the first quadrant? And yes. So that is exactly the same as the tan of theta. It's going to give you exactly the same value. Again, what's the point? Why are we doing this? Because we'll only know how to evaluate first quadrant angles. We have to turn everything into a first quadrant angle to help us evaluate these. All right, let's go cosine of pi take away theta. All right, so we're at pi, and what we're going to do is rock back theta. Okay, so what does that mean? Now remember, we go positive direction and negative direction. Negative direction is clockwise. That's saying go to pi and then rock back theta. So we're going to go to here, and that's going to be theta there. Right, so noting that this value here is going to be negative. Okay, the x value, because it's cosine, is going to be negative. Well, I don't know how to evaluate second quadrant angles. What I do know how to evaluate is first quadrant angles. So if I actually look at symmetry there and go, all right, I'm going to evaluate theta there, okay, and work out the positive value, that will give me this one here. And then if I drop a negative sign out the front of it, it'll swing over to there, and it's going to give us that value there. So this will be exactly the same as the negative cosine of theta. It's going to give you exactly the same result. Now again, forget negatives or positives. Some students who tell me, oh, I'm just, what's the pattern? What do I just need to go and memorize? Don't know. There's no correlation though between positives, negatives, and whether it's negative or not. The correlation is if the picture says it's negative, okay? But there's no, oh, this is a negative here, so it's going to be a negative in the answer. Let's just see what happens. I don't even know. Right, we want 180 take away theta. So we're going to go to 180, rock back theta, and what we want is the sign. Now the sign is the y value there, okay? So I look across there, and that's going to be that value there that I want. Now remember, we can't evaluate second quadrant angles. We will only be able to evaluate first quadrant angles. So what I would do is get the positive one, okay, or the first quadrant version, okay, which will also give us that value there. So this is going to be exactly the same as the sine of theta. It's going to generate exactly the same answer. All right, and notice again, that's not negative. This one here is negative, so negative goes out the front. This one's negative, and positive goes out the front. Okay, again, there's no way to work out what's going to happen unless you want to go ahead and memorize or commit this stuff to memory here. Okay, and that table to me is so much noise going on there that it hurts my brain. I can't even begin to comprehend what this thing is about. Whereas if you look at the picture, you just cannot go wrong. Okay, what we've got here is cosine 2 pi take theta. So we want to go 2 pi and then rock back theta. So again, where are we? We're in the third quadrant, okay? And what we want is the cosine value there. That's going to be the x value. All right, so that would be theta there, for argument's sake, which I would get the first quadrant version of theta, which will be this one here, which will give us the same value there. So that actually is going to be the cosine of theta. All right, there's a bit of noise going on here, so I'll just get rid of the writing so I can draw a fresh unit circle for this last one. Okay, what we want is the sine of negative theta. So that means starting here, we're going to rock back theta. So this is where we end up. All right, now noting that the sine value there is negative, okay, but I don't know how to evaluate these in the fourth quadrant. So what I would do is if that's theta, I'm just going to draw it in the first quadrant, okay, which is there, which will give us this y value here, okay. So why don't I do that, get the sine of theta in the first quadrant, which will give us a positive answer, stick a negative out the front, and what it will do is swing me down to that point there. All right, so again, very important to practice these, and if you don't understand it or you've practiced it and you're still not sure how these values are coming out, you need to jump on and meet with me and talk, okay, talk it through. Okay, the sine of x is equal to 0.6. This is, we're being told this. Okay, sine of x is equal to 0.6. So what I'm going to do is draw that. Okay, so sine is the y value. So there's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Okay, so that would be where we're going to hit. So this sine value here, okay, that value there is 0.6. Okay, and we'll just sort of say that this is theta over here, at this angle here. All right, so let's have a look at what they want us to work out if that value is given to us. Sine of pi take away x. Okay, so we're going to start at pi and rock back 0.6. Okay, so start at pi, which is 180 degrees, and rock back x, or theta. Okay, so we're going to go back that far. Now you can see it's roughly 45. So we're going to go to 45 back, which is, what's that? It's like 135. It's going to be here. Okay, so there it is there, and that would be the angle opened up. So starting at 180, rocking back to there. Okay. Now, what we want is the sine. So we want this sine of pi take away x. We want to work that one out. So we want to get the sine, which is this value here. And note that it will be exactly the same as the sine of x. So what we know is that this value here that's generated will be exactly the same as the value generated in the first quadrant. And we know that the sine of x is 0.6 already. So we can just say that this answer here is going to be also 0.6. All right, what's the next one they want us to do? Pi plus x. Okay, so that's one is basically saying start at 180 and then go plus x. So it's roughly up to 225. So that's what we're after there. We want to get to there. And what do we want? So that's theta that's opened up, theta more than 180. And what we want is the sine, that's the y value. We want this one here. All right, well, I don't know what that one is, okay, because I can't evaluate second, third, and fourth quadrant angles. So what I'm going to do is go back to my first quadrant and note that the sine of theta, or sine of x in the first quadrant, is 0.6. Over here, what do we know? It's going to be negative 0.6. So the way I'm going to work this one out is say that the sine of pi plus x is going to be exactly the same as the negative sine of x. That is, grab the sine of x, which will be this value here, chop a negative sign or chuck a negative sign in front of it, and it's going to spring you down to there. Okay, so that's going to be negative 0.6. 2 pi take x. So we're starting at 2 pi and we're going to rock back x, which will take us to here. Okay, and note that that's the y value there. So what we're going to do is the same thing. So we've got sine of 2 pi take x, which is going to be exactly the same as the negative sine of x. That is, do it in the first quadrant, get the positive, stick a negative sign out the front, and you're going to get the negative answer. So that's negative 0.6 again. All right. And one last one from this one, sine of negative x. So starting at 0, we're going to go negative x, which is to there, which will be exactly the same as, so sine of negative x will be exactly the same as the negative sine of x, which will be negative 0.6. So it's going to generate exactly the same value there. Right, so use your unit circles for those ones there, girls. Okay, let's do this one here. All right, so we know that the cosine of x is equal to 0.8. Find the value of. Okay, so I'd encourage you to use unit circles, but I'm going to work these ones out using like what I call my crappy unit circle. Okay, so here it is. Here's my crappy unit circle, and I'm starting at 180 and I'm rocking back negative x, where the cosine is 0.8. So let's just roughly draw what that might look like. Cosine is the x value. Okay, so that's that value there. And they're saying that the distance from there to there is 0.8. Okay, that's what the cosine of an angle is 0.8. Okay, so they want us to start at 180 and head back this amount here, whatever that is. We're going to head back there. Okay, and what we want is the cosine. We want the value at that point there. Now note that we have difficulty evaluating second, third and fourth quadrant angles, but we do know that in the first quadrant the sine of x is equal to 0.8. This will actually be equal to negative 0.8. We can see there that by symmetry it's going to be exactly the same value here, or exactly the same distance away, but albeit negative. So let's just say this is exactly the same as the negative cosine of x. That is, find the value in the first quadrant, stick a negative out the front, and you get the value in the second quadrant. Negative 0.8. 180 plus x. So we're going 180 and x more. That means that it's going to be negative, okay, and by symmetry it's going to be exactly the same value. So this one here will be negative cosine of x as well, which is negative 0.8. And again, emphasizes the point that the negatives are negative because of the picture, not because of any rote learned method that I've got. Oh, if it's a positive in the answer, except when this is negative, and in the third quadrant, I wouldn't have a clue. Just look at the picture and you'll be able to work out whether it's negative or positive. All right, rant over. 360 around, rock back x. All right. So if we rock back x, and remember we're after cosine, which is the x value there, this is exactly the same as the cosine of x. All right, so that's going to be positive. Okay, it's going to be 0.8 there. All right, this last one, we want the cosine of negative x, which starts at 0. Over here, it rocks back there, which is the positive, which is exactly the same as the cosine of x, which is 0.8. All right, they do take some practice. All right, let's do this one here. Sine of pi plus x. Okay, so what's the sine of x is 0.56. So we want to go pi more and we want to go that much more. Okay, so we're going to go x more. All right, now that would be exactly the same. We want the sine. Okay, so the sine there is negative. So why don't I go to the first quadrant and go x in that direction, which will be positive, drop a negative sign in front of it and get this value here. So I'm going to say that this is in fact negative sine of x, which is negative 0.56. Okay, so let's do this next one here. We're at 2 pi and we're going back alpha. So alpha is this amount here. So it's an angle somewhere between 0 and 90. So we're starting at 2 pi here and going back alpha. So I'm going to make it up and say it's there. Okay, just for, that's not theta, that's alpha. Okay, so where's it going to hit the tangent? It's going to hit it there. Why don't I get alpha in the first quadrant, which will be positive, and then negate it to bring me down to here. So this is going to be the same as negative tan of alpha. And tan of alpha is 0.47, so negative 0.47. Okay, cosine of pi take away theta. So we're at pi, we're going to go back theta, whatever theta is. Okay, so cosine is the x value. Why don't I get theta in the first quadrant, negate it, and it'll get me the value in the second quadrant. So we're going to say that this is negative cosine of alpha. Cosine of alpha is 0.91. It's going to be negative 0.91. All right, down here we're going to get the tan of alpha, pi plus alpha. So here's pi, and we're going to go alpha more. Where's it going to hit the tangent? It's going to hit the tangent there. So this would be the same as getting tan of alpha in the first quadrant, and that would be 0.47. So I'm try to keep that up so I can see it. 0.47. Cosine of pi plus theta. So we're at pi, and we're going to go theta more. So this is what we want here, and we want this x value. So why don't we do it in the first quadrant and negate it to get the negative version of that. So that's negative cosine of theta. Cosine of theta is 0.91, negative 0.91. 2 pi take x. So we're at 2 pi, and we're going to rock back x. There we are there, and we want the sign. So why don't we get x in the first quadrant, which will be this one, stick a negative out the front. So that's negative sine of x. Sine of x is negative 0.56. Okay, so there are the symmetry properties there, girls, and that takes considerable practice. So I'm going to get you to do those problems there. Plus, there's going to be a worksheet, I can spell worksheet, on Firefly there for you to do some further practice of that. Okay, so again, at this stage, it's going to be practice, 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 practice.